for lathe, for tinning, and so on. So when we said main program, that means we are going to continue about the program from the start line until the end. So this we call it the main program. Inside this, like in the normal or the high language programming, when you talk about the C++, for example, that you already learned, so the complete program represent the .cc file. So if you have usually the C++ has two main files, one .cc, one .h. So in the .h we only define the functions, we define the parameters. But in the .cc file we include all our functions that we are going to use. Inside this .cc file we are going to call some functions or some libraries from outside. So we have sub-programs. So the main program may include some of sub-programs. These sub-programs may be put or developed in a separate files, or it can be developed inside the main file. Okay, so sometimes in the C++, you are going to call a function which is not in the main script or in the main .cc file of your code. So you are going to call it from other libraries, from other files. Okay, sometimes you are going to develop a function, for example, not in the middle, function at the end, then you are going to call this function to the end of this program. The same is for the CNC programming here, or the G code. We have the main program, and this main program is consists from the blocks and several blocks. Inside this main program, we may call some sub-programs. And these sub-programs, why we need to develop such sub-programs? Because sometimes you have the same action you need to repeat for 100 times, for 1,000 times. So no need to recode it again. I mean, every line you code this one again, you repeat it by writing, because this makes the program is complicated. So in order to make the program is more readable for the programmer or for the user, so we are going to develop some sub-programs. So in each sub-program, if we need to call or to perform this task for that program in this sub-program, we're just going to call this sub-program. Okay. So this sub-program usually are small program which develop outside the main program. Then we can call with a specific address to complete a specific task. We are going to call it repeatedly, and after the sub-program is finished, it will repeat again into the main program. So this is the if we previously we highlight the structure of the main program, and we said the first part here in the main program, which consists from, if you see any example for the program, we are not going to see in detail. Now maybe you are confused, what is this and what is G90, M06, M03, all these already listed in the table before. But now if you have such example of the program, what is the structure of this program, or what are the main part of this program? So in the beginning here, you can see this sign here. This sign always to initiate the program or to start the program. Then you can see here the program number. Then you are going to see the program setup. So the program setup here, all the commands that need to be carried out or conducted in order to set up the NC machines. Okay, define some tools, define the speed, define the the rapid transfer, and so on. Then you go to the second part, which is the material removal. And in this material removal, we are going to do the drilling, the milling, and so on. That means the action that will be taken on the workpiece. Then we have the system shutdown at the end. So each program should consist from these main three parts: program setup, material removal, and system shutdown. Each part has its own commands or its own codes that we are going to use. So as we can see here, this is the program setup part. So the program setup consists from these parts, which is program start flag, 4-digit program number. So this program number is 1001. Maybe there is another program is 1005, 10010. It depends on, it consists from 4-digit program number. So why we need program number or program title here? Because inside the CNC machine MCU, you have many programs. Okay, So in order to save each program separately, and then later on you can go to this program to use, so you already know which is the number of this program. So for example, you say this under the number 1001, you should have a list outside, I mean a list or note. You write 1001 program is used to conduct such task. 1005 is used to conduct another task. Later on, after all this program already in your MCU, just the operator or just go to select the program number and then just run this program or execute that program. Then here, the other part also for the setup of the program, we define the absolute mode or incremental mode, define the units of the program. Yes. What is that one? Why the buzz? Who raise hand? Hello? No response? Continue. Okay, continue. Okay, so this is the first part of the program, which is the program setup, we said. And these are the main function or main words that use to program setup. This is stop the tool change, use tool number 2. For example, when we say T2, that means we are going to use the tool number 2. Here, turn the spindle clockwise at the speed of 1,200 and so on. We are going to go through all these commands later on. Okay, just here you need to know some of the or overview about the program structure. The second part here, which will be the material removal, and in this part, the program includes the code which is responsible to conduct the task, either for drilling, for milling, for any other machining operation. So the first, for example, here, rapid move to these coordinates, rapid down Z on the Z axis to touch the part or the workpiece, feed down this rate, feed for X2 and X3, move to also fast move to Z1. All these involved in the task that we need to conduct on the workpiece, either cutting, make hole, drawings, whatever is the task that we require from the machine to do. So all these part or word with address will be defined in this part, which we call it the material removal part. The last part of the program will be related to the stop of the program or stop of the machine. So for example, here we use M05, turn the spindle off, then M30 end the program. So until this point, for example, the program is complete, or the third part of the program is complete. It depends on how long is your program. What are, for example, if you have program to make one hole on the workpiece, it's not the same like if you have program to make 100 holes. Okay, if you have a program to cut one piece, it's not like the program that to cut 10 pieces, for example. So the most different or the difference between program will be placed in this area, in the material removal part. Other part, which is the start or the setup, the end, usually it is common for all programs. So this you already know the block configuration, and here just more details about how many digits we need to use. For example, for the numbering, we need to use for the sequence of the block, we need to use 4 number here or 4 digit. For the G here, it has 2 digits. For X coordinate, we have 2 digits, for example, 0.1, or you may have 3 digit 0.1 and so on. For X, Y, Z, for the speed also we have 4 digits. For the miscellaneous function, we have 2 digits. For the spindle function, we have 4 digits, and for the tool function, we have 2 digits, and so on. And this is the last end of the block signal. So we start from the addressing here. So we said the addressing here, this address will be placed in front for each block. So whatever is the number of blocks that you have in your program, so each block will have one specific number. Why we need this numbering? We said because it's easy for you to refer to if you want to modify the program, if you want to detect the error in the program, if you want to repeat some of these parts of the program. So you should have such numbering for your blocks. So for example, usually we have, for example, we use 5, 10, 15, 20. I mean, it should be like somehow sequential order. It doesn't mean it should be, must be 1, 2, 3. No, you can use any numbering, but this numbering, it shows some increment in the line number. So it's easy later on to follow and to find the specific block of program, either to add or to modify. Before you start to write the program, before you start to run the machine, you already write the program. I mean, you are starting to write the program, but before you start to write the machine, to run the machine, and you need to define some of the reference points. This we already mentioned in chapter 2 for the for the part 0 reference, and here also we need to sometimes we need to define some of the point point setting. I already shared with you one. There is like 3-4 videos in Kalam you can go through, okay, for YouTube to show you how the machine or how impractical we can set the point or the 0 point setting for the program. I mean, how you can adjust the spindles to reach to the on the top of the workpiece. Don't touch exactly. Just to touch, but not do anything. Okay. So we need to define the 0 point for the workpiece. We need to define the 0 point for the machine. We need to define the 0 point or the general reference point for the whole system. So 4 type of zeros here need to be defined, and this is the sign that you may find in the drawings and also on the CNC machines for define the machine 0 point. So it starts with or it's indicated by the letter M, so we call it machine 0 point. W here, work part 0 point, and R reference point, E to reference point. Okay, so all these reference points with their sign or their indicator here, you may see either in the drawings like we see previously in chapter 2, or you can see also on the machine when you have the drawings for the CNC machine. How to program these parts or how to define these reference points. You can see here, you need to define, there is one part of the code or one word, they call it G28, and this G28 is used to set the machine to the reference point. So for example, before I start to do any work on this workpiece or on this object, I need to define where is the machine 0 point on the work table. So for example, this is the machine 0 point for the work table. This is the machine or the reference point or the maximum level that the machine can reach. For example, if this spindle is moved, go to this way, like in this horizontal way. The table will go in horizontal way, the spindle will go up and down. So what is the maximum speed that this work table can reach? For example, the maximum place or location that the table can reach, and what is the maximum location here can be reached, and what is the or how to adjust or to set the place of spindle with respect to the workpiece. Last time we mentioned for the top left corner. So we said sometimes we use the left top corner as a reference on top of the workpiece. Okay, so with respect to this point or to the reference point of the machine, this is the left top corner of the object. Okay, so here you can see also here, this is the part, and here is the part reference 0 at this point, and here is the part or the machine reference point 0. So why we need to define these references? Because this part will be moved on this table. So I should know how long it moved from the reference point. The spindle also will move towards and away from the workpiece. So I need to know where is the reference point on this workpiece. So if I want to draw a hole, like in the on the coordinate of 5 x5, y3 with respect to this reference point. So for example, it will be at this point. The coordinates is changed with respect to this reference points, it will be at this point, and so on. So we need to define this reference point, also the point of origin here, in order to say, last time we said we need to define the center for if we have cylindrical shape and so on, in order to, when we find the coordinates by using the either radial or diameter and so on, we need to define the origin here to know where is the center of this object. From the center, for example, the top of the center is identical with the bottom of the object. So in this case, for example, we are going to consider for the diameter or for the radius of this object with respect to the central point or central object. How to represent this, or how to translate or how to convert such actions into a code in order to tell the machine, please go to this point as, or take this reference point as your reference. For example, we have in the line 1 here, the first line we write G28. The G28 is responsible to send the spindle to the home 0 position or return to the reference point. So when I give the command G28 to the spindle will go to the reference point. Mean after I finish my task, for example, after when I start my task, I send the spindle to the 0 point. After I finish, I will return it to the 0 point. So for example here, the most common 0 point for the reference point is 0, 0, 0. Why 0, 0, 0? Because when you put your reference either for XY plane, XZ plane, or ZY plane, your reference is 0, 0. So if you use the absolute coordinate, it's very easy for you to know where is the location of the spindle or the location of the work that need to be done on the workpiece. Okay, when you have here another command which is G92, so the G92 here, it will specify the new position. Here for G28 it will send it to 0, 0, 0, but here we're going to specify new position which is 3, 4, Y4, 20, and Z is 5. The position of the machine will reference as a part 0 for program 0 shape. So that means you are going to define a specific reference for your own working or specific for this type of objects. As I told you, there is one video. The title is Zero Reference. For the how to set the zero reference and also the setting part of the machine. You are going to find it in Kalam. Please go through. To understand how we can adjust the spindle to be close to the workpiece, how we can initiate our work, or what are the settings that we need to do before we start our work for CNC machine. Another word that we use in our block or in our CNC programming blocks, which is the coordinate words. So the coordinate words, always we already see it from the beginning when we start to write this type of example for the code. For example, when you have N1, G20, then you have X0, Y0, Z0, you have here X3, Y4, Z5. All this we call it coordinate words. So coordinate words actually are word which start with address. This address define which coordinate I am working on. Is it x-axis? Is it y-axis? Is it z-axis? And also we may have IJK or UVW, as we mentioned before, if we have shift for this 3 axis, or also if we are talking about the interpolation or circular interpolation. So on all these cases, when we have such letter to define the coordinates, then after it we have a value here. So this value either 150, 10, 3, 5, whatever is the combination of the address with this word, with this number, we call it the word coordinate word. So always the coordinate word are the most important values in your code. For that, we learn how to read these dimensions in the blueprint chapter. Okay, so unless you know the coordinates, if you don't know the coordinates, you cannot perform any task on the object. Unless you want to do something is randomly, just I want to cut. I don't care, cut 5 millimeter or cut 100 millimeter. So if you want just to perform cut, so you can do it. If you want to perform or to make a hole in this object in any place, you can do it with that coordinate. But if you want to make any task or any action on the workpiece at specific point, you need to define these coordinates in x-axis, y-axis, and also z-axis. The tool function, previously we mentioned about the tool function when we talk about the main elements that we need to know before we start to write the program. So the tool function here use the address T. So we are going to use the letter T here, and after T we need to define a number. So this number represents the number of the tools. As you can see here, the automatic tool changer. This is automatic tool changer exists inside the machine. I mean, is a part of the CNC machine. So this part of CNC machine place or hold the tools that can be used. For example, if, as I asked last class, I said if you have a drill, so inside the box of the drill you have many type of screw. So it maybe depends on the type, depends on the length, depends on the diameter, and so on. So this type of tools, if you want to change in the CNC machine, it will be changed automatically. You are not required to take out, plug out, and plug in machine. I mean tools. There is automatic tool changer which is responsible to perform this change of the tools. So what you need to do in your program, you just need to specify which tool you want to do. You want to use. For example, I want to use a hole with a diameter of 2 millimeter. So you need to take the proper tool from this tools, like toolbox, for example. So how to take this tool? You are going to specify the number of this tool. So if you say T04, the machine will use this tool. If you say T08, the machine will use this tool. Okay, so it depends on which tool you require to do your task and so on. One other parameter that you need to define in your program, we call it the spindle function, or S function here. The spindle function, it reflects the speed of the spindle, how fast you want the spindle to move. Okay, the speed of the spindle here is with respect to the workpiece. So for example, I have the workpiece in this area, and I want the spindle to move from this point to that point at specific speed. So I make the first task here, then I want the spindle to move to this point. I'm going to define the coordinates, but I need also to define the speed of movement. Why? Because this speed of movement will respect how fast I'm going to complete my task. If you want to make 100 holes on this box, so imagine the time that you require to do such holes. So for example, the machine will make the first hole, then move to the second, move to the third, fourth, and so on. So all these need to define what is the speed to move from one place to another place. So how we define the speed? The speed actually is a calculated value. It can be calculated based on this formula, and usually there are some based on the CNC machine. There are some or there is a rated or range for defining speed. For example, some machine from 10,000 to 20,000 or 15,000, 7,000. It depends on what is the speed that you require for the spindle to move. So the spindle speed here equal to surface cutting speed in meter per minute times 1,000, because we are talking about millimeter here. So you need to convert into millimeter over pi because we are talking about the rotating of the spindle here, cutter diameter in millimeter. Okay, so the cutter diameter in millimeter also, it depends. So these are the parameters that the spindle speed need to define. But what we do in our program, for example, if you ask to write a program, you are not going to. You will be provided with this spindle speed. I mean, for example, you said if the spindle speed is 1,000, so how you are going to represent it in your code? So you are going to say S1000. If the spindle speed is 7,000, so this code will be S7000. If the spindle speed is 10,000, this code will be S10,000 and so on. Okay, so for each work you are going to perform, there is a specific speed or rated speed need to be input to the CNC machine. Depends on the workpiece. For example, when you work with aluminum, it's not like when you work with the wood, not like when you work with plastic. when you work with a small piece, is not like the same. I mean, if you have small piece, so no need to move very fast with high speed. So maybe you need slower speed because the area on the workpiece is very small. So no place to take, I mean, to go in. It depends. It's like in the highway. Sometimes in the highway you can go with a very high speed, but if you have a narrow road, so you have to go with slower speed. The same is for the spindle here. So depends on the requirement for the task that you are going to perform on the object. So you are going to select your specific speed. Feed function here, another parameter or another criteria need to be defined in the program by using the address F. So if you see the address F in the code, that means it is related to the feed function, and it is program value. Actually, it will be calculated based on the for the feed rate here equal to chip load over tooth of the spindle here times the number of tooth times the spindle speed. All this involved. I mean, even this spindle speed here that we calculate here is involved in the feed rate of the machine or of the CNC machine. Usually, the feed rate here is I mean, is calculated based on the can be measured in the either in millimeter per minute or in inch per minute or also millimeter per revolution. What you need to do here, what you need to know, if you see F in your code or you are given the feed rate, which is, for example, 50, in your code you should have such F50. And this feed rate actually is not fixed for all the code. No, it should be feed rate when you need to use feed rate. I mean, you need to define the feed rate only when you need to define or to use the feed rate. For example, if you want to use the rapid traverse, that means the spindle will move at high speed from point A to point B, and you don't need the spindle to do any task, so you just move, so no need to define that feed rate. But if you want the spindle to perform some task in the middle between these 2 points, either hauling, milling, so you need to define your feed rate here. The movement of the tool here, for, for the feed function here can be defined according to the two measurement system. If it is G20, if we use G20, so the unit of the feed rate will be in inch per minute. If you use G21, so the feed rate will be millimeter per minute. It depends. So I mean, since we said the feed rate, it may be measured in millimeter per minute or in milli-inch per minute. So this will be totally depends on what is the measurement standard that we use in our program. Is it G20? So it is in inch. Is it G21? So it is in millimeter. This is the work setting also. It's more related to the definition of the reference, definition of the place of the object with respect to the spindle, definition of the work, the place of the object with respect to the table of the machine, and so on. Mean to define the 0 for the reference point, the 0 for the object, the 0 for the machine, the place of the spindle with respect to the workpiece. That means how close is the spindle to the workpiece, or how far is the spindle from the workpiece. All these settings and offsets need to be defined in the beginning of the running the machine. I mean, before you start to run or execute your program, you need to conduct some of these settings for the machine. Either through program, that means you are going to, like we said before, we need to have some settings in this slide of the program. We said we have some part which is of the program need for the program setup. So here we need to define some of the settings here or setup, like when we select the tool, when we define the speed and so on. All this related to the setup. This is for the software part, but for the hardware part, that means you need to adjust the position of spindle with respect to the object. You need to place the workpiece or the object on the table of the machine. Okay, so all these need to be setting and offset need to be defined before you run your machine. So as you can see here, the tool change position here. This is the 0 for move to the hole. We need to define the 0 point. This is the work setting. Who need to define where you are going to perform the task or perform make holing or drawing and so on. You need to define the offset. What is the place of the spindle with respect to the workpiece? What is the distance between these two objects? I mean, because sometimes if this spindle is close or more closer to the object, maybe it may crash the machine or maybe this tool will be broken. Imagine that you have this one steel and you fix this one you make it tied to this object or very close to this object. When the movement starts, maybe this will be effective. What you need to do here, you need to adjust the spindle before the move, because the first movement will be fast traverse. So the fast or the rapid traverse here need to have some space between the spindle and the work object. So that we call it the offsets that we need to define. And this can be done manually by the operator of the machine, or can be adjusted through entering some of the code to specify or to define the reference point of the object and the reference point for the machine and reference point also for the start point for operation of the machine. Also, this one you can find in the video. Please go through the video, okay? After the class, you may go through the video and you can understand more, because when you see the machine is working and how they adjust the machine and so on, so it's very easy to understand how they can settle this offset and work setting and also 0 points. Okay, so this is the G code or preparatory function we already mentioned before. So now we are going to define some of the more common G code that we usually use in our coding. Okay, so also there is one video talk about the most 9 codes that you need to know before you start programming. Okay, so there are some of the codes which is frequently used in programming CNC machines. And this code, maybe when you use it for the first time, it's a little bit difficult to memorize, but with practice, when you use it multiple times, it becomes easy for you to which code should I need or should I use for this action, which code should I use for that action and so on. So the common, as we said before, the G code here consists from the G letter and 2 digits, and this 2 digit is changed. According to this 2 digit also, we can each number here will specify what is the preparatory function that need to be carried out. So the subprogram that we mentioned before, or we said when we have a program consists from a main program and subprogram, what is the subprogram should have? This is the definition for the subprogram. It is a separate program called up by another program. So as we said, we have main program, we have some subprograms. So we want to call this subprogram to be repeated many times, or to be repeated for 1 time, 2 times, whatever. But I use it like my ready function to be used. Okay, so I call this subprogram. How we can call this subprogram? There is some code which will be used to call this subprogram. So here we can see we have 2 types of code that will be used with the subprogram. One, we call it M98, and the other is M99. So M98 here, if I have this M98 and I write after it the program number, we said every program or every subprogram, it has a number. So either program or subprogram, it has a number. So usually the subprogram, it has a number also consists from P and 4 digits. So I want to call this program like when I said M98P2000. So this command will call this program, which is P2000. What inside B2000? It will be same like normal code like G00, G01, G02, and so on. But this type or this program, I'm going to use it, I mean, more frequent or more repeatedly. Okay, so instead of reprogram it many times or rewrite it many times, those I have a very long main program, better to call the sub program, then return again to the main program. Okay, so this is the how we can, this is the example how to call the sub program. For example, we can put it within the code. So for example, here we have G01, it should have here also N01 or N02, whatever, but it's as I told you, maybe I mean, we are not going now, when we have some examples, it shouldn't be complete, just to show you our focusing on M89. So we do not focus here to write the number and so on, just focus how to use M99 with the subprogram 1000, for example. So this code here will call the subprogram number P1000. How we can return to the main program? We are going to return to the main program by M99 for this one. This will control, I mean, this with M99 here will be to beat you to the or the main program here. Another way, we need also, we may call, I mean, if we want to call the subprogram for several times, I mean, like I make B89 for B1000, but I want it to be repeated for 100 times. I want to be repeated for 20 times and so on. So in this case, we are going to use such formula. B99, 98. This one represents the number of times that I want to call. So I said B, this is the number of times. I want to call it 100 times, so this will come 100. I want to call it 50 times, this will be 50. I want to call it 10 times, this will be 10. Then here is the number of, or the program number. So like we said before, it's 1000. So this 1000 represents the number of the program. So when we said here, M98, B10 for 0001. This 4 digits represent the program name. We said the program name or program number we said from 4 digits. So this program number, and this one is the how many times I want it to be repeated. Is here we say 10 times. So if you want to read this command, can be like subprogram number 0001 will be called or will be returned for 10 times. How this subprogram will be involved in the main program structure? It is, I mean, this is the structure that we already defined, but this one, this code here is generated by using software. So by using CodeCamp software. So usually it has more information here on the top, but the same is still the main program or the removal part and the end program and also the setup program here. And then here we have the program number. Okay, so where is the subprogram will be placed here? The subprogram will be placed inside this code. So if you want to call any of the subprogram, you need just to add, for example, M in any line here, M98, and you write the program number, which is, for example, 1000. So in this case, it will call the subprogram number 1000. As you can see here, so this is the main program. This is the how I call the subprogram M98 B1000. So this will call this subprogram because this number is 1000. If it is B2000, so it will call that subprogram. So I here I put the number of the program. Then this program is subprogram is go down in subprogram. I can also call another subprogram. So I use also the same M98 B2000. So this P2000 will call the subprogram number 2. So we have here one loop nesting, and here we have two loop nesting. Why two loop? Because we have subprogram. Inside the subprogram, we have another subprogram. So we have two subprograms, and here after we finish here, at the end of this one, you can see M99. We said M91 to call the subprogram, M99 to end the subprogram. After this one end, it will return again, go for the next line, which is 90, 100, and so on.